page is this on the this is an actual book, correct?
This is the actual book. Let's do question number 3.
Wouldn't it be B?
I haven't done it yet.
Oh.
Hold on. I gotta eat and do it at the same time, so. The p-value. All right, I got what I think it is. What do you say it was?
I think it's B.
How about the rest of you?
Based on what we're getting the answer, like the question just starts with, is there good evidence?
Yeah, well, use the numbers that they gave you. What numbers did they give you in this problem?
Are you talking about the multiple choices, or like there's numbers before that?
The multiple choice is just to check what your answer is. What did they give you in the problem? What are we using to get the answer here?
We're using the chart that's like above.
Oh, I think I'm confused. So number 3 starts with the does nature heal better?
Yes.
Oh, there you go. Okay, never mind.
Right. Lorena, was that you? Who's talking just now?
Yeah, I was saying that
Okay.
when we use the chart.
So you don't need the chart actually,
Oh, okay.
because what do they give you right after the chart?
They give you the mean and then the standard deviation and like the differences.
Right. If I use the chart, I can compute those, but they were so nice they provided it for us.
They were nice.
They were nice.
Can you explain that again, please?
Which part?
Just like what you did with the standard deviation and mean.
Well, the first question is this an interval or a test? Which section do we want to work on in our calculator? Interval or test?
Okay.
Huh?
Is it a test?
Yeah, because p-values are tests. Okay. Is it for proportions or for means?
Proportions.
Okay. It's not. Look at the numbers that we're getting, 25 or 13. These are not proportions, these are values,
Yes.
right? Plus the line after the chart says the mean and standard deviation, right?
Yes.
Now, is it one sample or two?
One.
One, because it's a matched pair test. So which section of the calculator are we going to use for this one? Every match pair test is always the same one. Which one is it? Anyone?
The one prop z-test.
No. It is
Well,
not.
the one was, sorry.
These are not proportions. It's not a one prop. It's a matched pair t-test. This is a t-test. Matched pair is always a t-test. Yes, no? Guys, if you're gonna beer, you gotta talk.
I
You gotta let me know what's going on in your minds. It can't be like class where I just assume everyone gets it because no one says anything. So talk to me. There's like 10 of you here. Talk. Say something. Please.
So, Professor, you said it was a t-test for this one?
Yes, we do not know sigma, so it's a t-test. In fact, they give you the sample standard deviation. They would only do that if it's a t-test. The question is it one-sided, two-sided? And if it's one-sided, which side?
I'm confused. I don't know which one it is.
Okay, well, they're asking, first of all, what are those numbers? In the two groups, the control group and the experimental group, all these numbers, what are those numbers?
They're the controlled experimentals, the difference, and whatever new is.
No, but what does what do the numbers mean? 25 what? 13 what? What
Would
are
it be like would it be like the unknown true value and then like the alternative hypothesis?
no? The values in the chart are measuring something. What are you got to read the question? What are they measuring in this case? Our bodies have a natural electrical field that is known to help wounds heal. Does changing the field strength slow healing?
Is it the
The following data are the healing rates of cuts, micrometers per hour. Right? Yes, no?
Yeah.
So 25 what? Micrometers per hour. 13 micrometers per hour and so on. Now, we're checking to see whether or not you can slow the healing. If you slow the healing down, what should happen? Do you get more micrometers per hour or less micrometers per hour of healing?
probably less?
Less. So the difference should be a positive number. Control minus experimental should be positive, right?
Yeah.
So we're checking to see whether or not it's positive enough. Is it close to zero? In which case there's no difference. Or is it greater than zero? In which case it does slow healing. So this is a test where we're checking the null hypothesis of equals zero, that there's no difference, to the alternative that it is greater than zero. Yes, no, maybe so?
Yes.
Yes.
And what does the calculator give us for that scenario? A p-value. What's the actual p-value? Guys, this should take seconds. So what is the disconnect? What are we not understanding here? Please talk to me. I can't help you if I don't know.
Would it be C?
What is your p-value? I don't care if it's A, B, C, or D.
I got 0.064.
Did you do a two-sided or a one-sided t-test?
I did two-sided.
But this is not a two-sided scenario.
Uh,
We're checking to see whether or not healing slowed.
okay. So would that be less than?
You tell me. If it's slowed, would the control minus experimental be positive or negative?
Positive.
And so we're checking to see if it's positive, which means compared to 0, would that be greater than or less than?
Greater than.
Greater than. The alternative is greater than 0.
Okay.
And what do we get?
I got 0.96. Oh, wait. I did something wrong.
I think you did do something wrong.
Yeah. 0.032.
Yep.
Okay.
Did we all get that? Something similar? Anyone? Hello?
How did you calculate that on the calculator? I'm confused.
Which section are you on?
Same section.
No, on the calculator. What section of the calculator do you want?
Oh, I'm on stat test.
Yeah. Which one?
It's not t-test, right?
Yes, it is a t-test.
It is.
Why wouldn't it be?
I selected the t-test from the beginning, but I didn't use it for some reason. So we're using this as a sample, right?
I don't understand what you mean. We're using what as a sample?
So because it's a sample mean and a sample standard deviation on the calculator when I click on the t-test.
Of course, if we had the population mean, I wouldn't have to do anything. If we had the population mean, we'd be done. The whole point is what's the population mean?
So on the U0, what should I put?
P0, you mean? Or mu,
Yeah.
mu 0.
Mu0, yeah.
If the null hypothesis is right, what's the mean going to be?
0?
0.
There you go.
Which formula did I use? I didn't use a formula. What do you mean? You mean on my calculator? Sebastian, what do you mean? Which formula did I use? It's not responding. Okay. Question 4, give a 99% confidence interval. Done. That's how long it should take.
You want the interval, right?
Read the question. What does it say?
Difference of healing rates.
Before that.
What was that? Sorry.
Before that, what does it say?
It says give a 99% confidence interval for the, so interval, right?
Yes.
Okay. Would it be negative 2.791?
To what?
And then to 14.211?
That's what I get.
Okay.
Does that jive with our p-value in question 3?
Yeah, it does, right?
Why?
Because the intervals between our p-value?
That doesn't make any sense. Sorry. Why does the confidence interval agree with the result of our hypothesis test? Come on, guys, we did this so many times in class. Why does the confidence interval agree with the hypothesis test?
Prove the hypothesis test?
Well, why do they have the same conclusion? The practical conclusion at the end is to do something, to physically do something, to make some decision. Why is the decision that we make using the confidence interval approach the same decision that we make using the hypothesis test approach? What is the decision for the hypothesis test approach? Reject the null hypothesis or not reject it?
We do not reject it
Why not?
because it's small.
Because it's not.
Oh, 'cause it's not. Wait. Doesn't this have to do with the hold on, sorry. Oh, because it's no, okay, we would reject it
Tell me why.
because the p-value is low.
Okay, if the p-value is low, the null must go, right?
Yeah. And I think the cutoff was 0.05.
Usually.
Yeah.
But if we compare it to question 4, what should the cutoff be?
Question 4 was the interval one.
Yeah. The n value on question 3. I mean, how many newts are there? How many yeah, you can just read it. Just it says there in the chart, there's 14 newts. It's a 99% confidence interval in question 4, which
1%, 0.01.
which means 0.01. So therefore, what do we do if we use 0.01? Do we reject or not reject in question 3?
Doesn't it depend if it like lands like in the critical region or crucial region, something like that?
Of course. But if we just use the p-value, we don't have to worry about the critical region. The p-value tells us, it gives us the same eventual result. If the p-value is less than your significance level, then you would reject. If it's not, you do not reject. So in this case, because my significance level is 0.01, I do not reject. So how do I know from the confidence interval that we created that you also do not reject? What tells you that in your confidence interval?
It's because there's a 1%, so 0.01, and we got 0.03 as our p. Or
No, that's the hypothesis test. I'm looking at the confidence interval now.
Oh, because all the values are in the interval
What values?
in the chart.
Oh, only one number that I care about. Only one number that matters. What's the only number that matters?
That is greater than -4. Right?
No. 0. The only number that matters is 0. 0 was the number that the null hypothesis said should be the difference. Is 0 in your confidence interval?
Yes.
Then you can't reject, because 0 might be the answer. When I get my confidence interval, any one of those numbers in between could be the true value. If 0's in there, 0 could be right. How are you going to reject 0 if 0 is smack dab in the middle? The only number that matters is what the null hypothesis is claiming. If that number is in there, you cannot reject. If that number is not in there, then you do reject. Right? We did it in class multiple times, right?
Yeah, we did it with the wine example and like the little the boys example.
Yeah, I mean, I vividly recall doing it. Of course, I teach like 5 classes, so sometimes I do forget. But I'm pretty sure we did it. I mean, you're confirming what that we did it, but I'm really certain that we did it.
For that chapter, I actually had a question on it.
Yeah.
So you know how for the earlier it was said that we do like 0.50, and you said that we don't always do that for the PO,
You mean
the mule.
0.50 for what?
For mule 0 or P0.
Right, but I'm saying every problem is different. So I don't know why I would say you always do something. I mean, the only time
No, not that we always do it, but like my question is like how would how would we find like PO 0?
Oh, well, you got to use common sense. Like if I say, hey, I think these dice are not fair, or I think that this coin is not fair, and you say, oh, okay, I'll do a hypothesis test. The null hypothesis is that they are fair, and if it's fair, it's 0.5.
Okay.
They don't got to tell you that. You have to just use your knowledge of the world and say, okay, well, if it's fair, then this is the value, without someone telling you what the value is. Make sense what I'm saying?
Yeah.
But to say it's always 0.5 otherwise, I mean, I can't claim that, but in those kind of scenarios, it would be.
Okay.
All right, question 5, question 6, 7, and 8. They're all from the same information. So let's do 5. Go ahead and do 5. Thank you, Michelle. Good luck. I'll put it up after I'm done. Question 5. Okay. Government server.
So for this one, it
Yeah.
would be sample T interval, right?
No.
Or T
Oh.
test.
No. You gotta read the question. It's not any test. It's not any interval. It's a simple calculation.
Oh, it's okay.
Gotta read the questions. What do we have, guys? This is a 1-second answer. Yes, 0.274. It should be immediate. How many male students played video games for 3 or more hours per day? Give me the number. How many?
1,926.
And how many male students are there?
Oh, 7,028.
So how do you find the proportion of males who played?
You go to menu.
No, don't need any of that.
You divide them.
You just divide them. 1926 divided by 7028. That's it. That's it. The proportion of males who played. How many males played divided by how many males there were. That's it. 6. What is my estimate for the proportion of females who played?
0.148.
Or 148. Bad, done. Now, the sampling distribution for the difference in the sample proportions has what standard error? This one should not be immediate.
Are we on question 7?
Yes. Yes, we are. All right, I got it. This was not immediate. This should be 4 lines of work. What are those 4 lines? Who wants to start me in the right direction?
So our sea level will be 0.99.
And why?
Because it tells us right there a 99% confidence interval for the, so then therefore that's yeah.
Okay, so you like kind of headed question 8 first.
Were we doing number 7?
Yeah, but 99% doesn't appear until question 8.
Okay, never mind. I take that back.
No. I did question 8 first because
Okay,
I needed question 8 to answer question 7.
okay.
Well, technically I didn't, but I used question 8 to answer question 7.
Yeah, so that's what I have put for my sea value, for my sea level.
Okay.
And then for the X, I had just gotten the sum of the male and the female of the students who were on the computer games for more than 3 hours.
Yeah.
And then for the X value, I just used the total amount.
Well, what's the formula for standard error? I mean, if they're asking for something, it wouldn't a good starting point be to use formulas that might contain it? Yes? No?
Yeah.
So what formula?
The Z star to the square root of P and parentheses 1 minus P over N plus 4. That's the margin of error equation.
N plus 4. That one.
It depends if we're using large or a small sample, but I think here is large, so it's over N. So it's P hat, not P total, right?
Yeah, I
Yeah.
mean, these samples are huge. 6,000, 7,000. We're not going to use a small sample confidence interval.
So I think it's Z star times square root of P hat 1 minus P hat over N.
That's for a single sample. We have 2 samples here,
Oh,
right?
Yeah, we have 2 samples. So we have the boys and the girls.
Right? And we're interested in the standard error for the difference between them, no?
Yeah, for the error.
So we need the correct formula for that. So what is that formula? This is the good part about having your formulas in the right place. So I actually did it the way that you're suggesting, and it's pretty close to the way I did it. My answer's a little better, but that's fairly close. So what's a formula that has standard error in it? So here's what I did. I answered question 8 first. I calculated my 99% confidence interval. In fact, I might as well do that. We'll need to do it anyways. Go ahead, calculate the 99% confidence interval. Go ahead and do that, please.
Professor, what would our standard deviation be for this?
You don't need to put it in. What do you mean? Which interval are you doing right now?
T interval?
It's not a T interval.
It's 2 proportion z-test?
It's 2 proportion Z interval,
Yeah,
Okay.
interval.
Interval, yeah.
right? We're dealing with proportions, the estimate of the proportion, sample proportions. The word proportion is all over the place. Every question, 5, 6, 7, 8, says the word proportion at least once.
No, I should know it because once there is a percentage, we should always use interval because it's a confidence interval.
Well, I don't know if that's necessarily true. I can think of scenarios, I think, where you would use percentage even if it's not. But certainly here, we are. So what is our confidence interval?
I'm pretty sure I did something wrong, but I got negative 0.126. And then I also got negative 0.125.
Well, that's not amongst the multiple choice, is it?
Yeah, so like,
So what do you put in? Which one did you go to?
so I went to menu, stat, confidence interval.
Which confidence interval?
I went to the 2 prop Z interval.
Okay, what do you put in for X1?
For X1, I put 1020. And then
Okay,
for my N1, I put 6,889.
okay,
For my X2, for that one, I put the 1,926 mils. And then for N2, I put 7,028. And then for my C level, I put the Z level that we were given in class for 99%, which is 2.576.
no. The C level is 0.99.
Oh.
You don't put in Z star. You put in the C level, 0.99.
Okay.
Okay, but the way you did it is backwards though, because you did the difference between females and males, not the difference between males and females. So your numbers are gonna be negative.
Oh, okay.
But if you ignore the negative sign, your number should be fine.
Okay.
In fact, what does everyone get for this one?
I ended up getting B if I switch
Okay.
my negatives and positives.
That's what I did. I got 0.1084 to 0.14357. Did
Okay.
everyone get that?
Yeah.
Everyone else, the silent majority.
I got negative numbers, but probably I did something wrong.
No, it just means you did female minus male, not male minus female. I just
Yeah.
mentioned that.
Yeah.
Okay, now. So Anahit, you two, you got negatives, or you two, you got it?
No, I got a negative also. I got like negative reciprocal of what you got.
Negative reciprocal.
Like I got negative 0.1436 and negative 0.1084.
Yeah, okay. So that's not negative reciprocals. That's just
My bad.
that's just the negatives. Okay, now how do I go from that to find the standard error? So the margin of error is Z star times the standard error. So how do I get the margin of error?
You do the Z square with a little square root thingy and then like everything inside.
No. From the confidence interval, how do I get the margin of error? Don't look down. You don't need any of that. It's just conceptual. From the confidence interval, how do I get the margin of error?
I don't know.
Yes, you do. You just don't remember. That's different than not knowing. This goes for everyone. How do you get the margin of error from the confidence interval?
It's the plus or minus part.
It's the plus or minus part.
Yeah.
So how do I get the plus or minus part?
You
You do the Z star.
No,
times the square root of-
From the confidence interval. We just got it.
Oh,
We
from
have a
the-
confidence interval. How do I get the plus or minus part? Everyone, come on. From the confidence interval, how do I get the center? How do I get the plus or minus part? This is simple algebra. Come on. is he here? Come on, Edward. That's funny. If my confidence interval was 0 to 10, how would I find the margin of error? What would it be? I'm out of turkey too.
Are you having turkey?
No, I'm out of turkey. I have none left.
Yeah, we ate all of ours on Thanksgiving dinner.
No leftovers?
Well, we had like a big gathering.
No, let's do
Well, it
it.
wasn't like big, but we had like 4 families there. So.
4 families. Nobody invited me. Don't think I didn't notice, by the way.
don't lie. I invited you.
Were you the one like up in San Diego or some shit like that?
No, I'm the one in Long Beach. I was like, oh, you can come to Long Beach if you want. And you were like, no, I'm good.
Yeah, long
I'm over here, Burbank.
Burbank. I'm not in Burbank.
Oh,
That nice, silly.
Man, I was silly. Guys, to find the margin of error, you take the difference between the ends and you divide by 2. The difference between the ends is how wide the interval is. So you divide it by 2, that's half as much. That's the plus or minus part. Yes, no, speak. Speak. Edward, come on.
would it be like extra work if you just do like if you just input everything like to the margin of error equation?
What margin of error equation?
You know, like that Z square with the little square root thing.
Yes, but the problem is, well, yeah, you can do it that way, but I'm trying to give you the most expeditious way. Everyone always complains, we don't have enough time to do the test. Well, if you do things the fast way, you'll save time. You can do it the long way. It's not wrong,
Mm,
but it's so much easier to do it the fast way, which is, I mean, how do I find the center? If I give you the margin of error, how do you find the point estimate of the center?
divide by 2.
Divide what by 2?
Divide whatever we got for number 8 by 2.
How can I divide an interval by 2?
Take
Interval,
the difference.
no. You take their sum. If you want to find the middle, you add them and divide by 2. It's an average.
Mm,
If you want the margin of error, you divide them, you subtract them and divide by 2. That's the margin of error part. And you said
So
that
then-
equal to Z star times the standard error. What's Z star in this case?
Z star. 2.576.
2.576. So if you take your margin of error and you divide by 2.576, you get the standard error.
Oh
Number 9. A sample survey of 1,497 adult internet users found that 36% consult the online collaborative encyclopedia Wikipedia. It's got to be more than that. I go Wikipedia every day. Anyways, give the standard error of p hat, the proportion of all adult internet users who refer to Wikipedia. Ah.
yeah. 36%.
And part B.
Give a 100% confidence to application. Internet users who refer to Wikipedia.
Okay. Is exactly the same as the last 2, 7 and 8. Well, not exactly the same, but strategically the same.
Mm, 1,000. Okay, I got 1.44
For what?
for number 9 part A.
I do not get that.
Okay.
Yeah, what I got is, that's correct.
What is correct?
No, what I got is correct.
Oh, okay.
I just checked the answer. First, find the margin of error. Sorry, first find the confidence interval. What is the confidence interval?
Um, 0.36.
That's the confidence interval, 0.36?
Yeah.
It's a weird confidence interval.
No, sorry. No, I was thinking about the last problem. Sorry. I was confusing the word.
Come on, out of heat, what is it?
What if he's 0.36? 0.335 and then 0.384.
That is the confidence interval.
Okay.
Did everyone get that confidence interval?
No. No.
No? Which interval on the calculator am I going to use for this?
One plus the interval.
Which one?
The one.
The interval.
The one prop Z interval. What do I put as my X?
Your X will be the 1,497.
No. That's my N.
1,000.
What is my X?
Hmm.
539.
539, yes. Tell everyone how you got that, please.
I just multiplied our n by 0.36.
And when you did that, what did you get?
I got 538.92, but I just rounded up.
Why can't X not be just the decimal that you get when you do it that way?
Because you can't, like have a fraction of a person.
That would be tough. But 539 is the closest value. So X is 539. What's N?
Your 1,497.
And what is the confidence? And what is that noise? It's like a little ditty. I kind of like it. What is that?
I like the ice cream truck that passes by my house.
That's your house? Your house makes noises?
No, like an ice cream truck passes by like throughout the day. It sells ice cream.
That's Tetris.
Well, yeah, but like they play that song or they play other songs.
It's like it is Tetris, right?
But I'm like I'll like go outside to get her better.
Yeah, seriously, this is killing me.
So for the confidence interval, I got
Yeah, you can like hear it better. Yeah. Soy paso. Okay, there.
No, I don't hear anything.
Yeah, because they're like leaving.
Oh, I want a jip. Okay, anyways, do we all get the right confidence interval?
I got 0.336 to 0.384.
Good. So what's the margin of error?
Margin of error. Do you want the standard of error? Just
The margin of error. What's the margin of error?
you add them and divide by 2.
No, adding them and dividing by 2 gives me the center.
That's
That's
an
Subtract them, you
average
subtract them by
of
2.
center.
I mean, you subtract and you divide by 2.
I said what?
You subtract them.
Yes. No.
I got 0.0059.
What do you get?
Hold up.
Uh,
0.0059.
What two numbers are you subtracting before dividing by 2?
0.354.
There is no 0.354.
Oh shit, that's what I thought. And then 0.366.
I didn't get that either.
Okay, never mind.
What do you put in for your confidence interval? Do you do 95% or 99%?
I put confident interval. Okay, so then for my X, I put the 500, like what he has said, the running time by 36. I put 539.
And what's your N?
And then my N was the 1,497.
And what's your C
And
level?
then for my C level, I put 0.36.
Oh, 95%.
Oh,
It's a 95% confidence interval.
okay.
So margin of error, I got 0.024,
Okay.
and then standard of error is 0.012.
That's what I got.
So basically, to get the standard of error, you do the margin of error, which you subtract the confidence interval and divide them by 2. And once you get that answer, divide it by the z.
That would work.
There you go. I got it.
So for
Thank
the
you.
margin of error, you guys got 0.024.
The margin of error,
Yeah, what did you guys get
Yes.
for margin of error? Okay.
0.024, yeah.
Okay.
Okay. Oh, an IQ test. All right, 10, 11, 12, and 13. Go ahead and start that. I'll be back in just a second. Oh, yeah. Okay. What do you guys get for 10? Should be done by now.
0.3707.
Good. Now, I didn't get exactly that. I got really, really close. So why didn't I get
On
it?
the calculator, it's 0.3694.
Yeah, that's what I got on my calculator.
Yeah, so I just put it 0.37 because it's the closest.
Yeah, so why would it be different? Probably because they want you to use like the table in the book, so the answer is a little off. Okay, but anyway, did we all get the right answer? Yes, no, maybe so? Anybody? Yes, okay. Next one, go. All right, I'm done. What do we have for number 11? Number 11, what do we get? NI. That stands for nocturnal intelligence. Oh, no. Nitrogen, no, it's nickel actually. Ni is nickel. N is nitrogen. NO. I don't think there's any elements. It's NO. Normal interval. That actually seems kind of appropriate. You know how I know my chemistry? You guys know how I know my chemistry?
You took chemistry.
I don't go anywhere without a periodic table. And of course, I took chemistry. So, you know. Chemistry. Not as good as physics, which is not as good as math, but you know, hey, teach their own, right? Anyways, come on. Number 11, what's the answer? Lorena, can you hear us now? Or you can always hear us, but we can't hear you. You didn't mute it by accident, did you? Or something? So why can't we hear you? Yeah, come on.
It's muted, so maybe you can like.
Yeah, but if it was muted, we wouldn't be able to hear her. It should be that we can't hear.
She can hear us.
But we can't hear her.
Yes, but we can't hear you.
I don't know about you, but this is like the perfect situation. This is great. I get to talk as much as I want. I don't have to listen to anyone else. That's wonderful. I'm gonna log out and log back in. Hold up. Anyways, come on, Edward. What's the answer?
I honestly don't know.
Oh, God, you're killing me here.
I think we're all just gonna do bad.
Yeah.
I think so. For the mean of
I don't-
x, is it just the mu?
The mean is the same.
So
How
it
many-
is 100.
Yeah.
So the standard deviation is the sigma over radical n.
Yes, we did like a million times. Remember the whole applet that we looked at like 19 times through the semester? Where the mean stays in the same place, but the spread shrinks by a factor of 1 over the square root of n. You know, that's our standard error formula, sigma over the square root
I
of
think
n.
I got it.
I hope so.
The standard deviation is 1.94. Mean is 100. So it's C.
What is that picture? I can't see that.
Like you're stressing out, like you see, like you need like a
The
massage.
head massage. Do you
Oh.
remember?
I know, I've already pulled that on my hair. I can't really do much else there. So, so what's the probability that the average WAIS score of an SRS of 60 people is 105 or higher? 105 or higher. Oh, done. Yeah, between this and the stock market, everything's not working out for me right now. Crypto.com.
Is it 0.0049?
Yes, it is 0.0049. Tell us how you got that, please.
So you do the same normal CDF, lower 105, higher 9s, and then the mean is 100, and standard deviation is 1.94, which we just got.
Yes. Yes. Okay. I don't ask questions like 13, so let's take a look. All right. Men and muscle. All right, men and muscle. 14, 15, 16, and 17. Let's do it.
All of them or 16 and 17?
No, 14, 15, 16, 17, all of them.
Oh, okay, okay, thank you.
Okay. Got it. When you get it, A, B, C, or D. Nobody's saying anything.
Don't you use two sample t interval?
Nope.
I did the T interval, but didn't get what they have.
Well, what did you get? Because they don't have intervals. They have center plus or minus margin of error. You got to take your value and rewrite it.
Wait, take the value I got and rewrite it, or their value?
You got a confidence interval, correct?
Yes.
But their form is center plus or minus margin of error. You got to take yours and interpret it.
Is it D?
No. What's your confidence interval?
Low 95%. So it'll be 2 point. Let's see that.
14 is C. That's correct. 14 is C. But everyone should get it.
Wait, how do you get the 0.35?
Did you get the center?
Honestly, I just got the confidence interval and I looked at that multiple choice and then I looked at which one fit my confidence interval.
Okay. Well, what was your confidence interval? From where to where?
It was 2.0014 and 2.6986.
How do I take those two numbers and find the center?
Wouldn't you subtract them? No, right?
No.
No.
You're gonna add them and then divide them by 2, no?
Add them and divide by 2. You're averaging the two numbers. That's the center. So when you add those two numbers and divide by 2, what do you get?
2.4493.
You got what?
Oh, maybe. Hold on. I probably did it wrong.
Maybe
35.
2.35. Once you have the center, how do you figure out how far it is to the edge? What's the easiest way once you have the center? Guys, this hurts. This really does hurt.
It hurts me more than it hurts you.
But it's not even statistics. It's just I mean, it's more basic than that. If you have two numbers, how do you find the distance between them?
Just subtract them.
Just subtract them. So once you have the center and the edge is 2.6986 and 2.35, you just subtract them. What do you get when you subtract them?
Hmm.
Someone answer, please. What two numbers are you subtracting from each other? Somebody speak! What's the center? We just calculated it. Someone read me the center.
The 2.35.
2.35. We just said it. What's the right edge?
Is it the 2 ends of your interval?
Well, the right edge of the interval is what?
It is 2.6986.
So how far is it from the right edge to the center?
1 second.
Negative 0.546.
What?
0.546 if you subtract them.
No. What numbers are you subtracting?
Negative 0.3486.
Well, you did smaller number minus bigger number, but yes, 0.3486. Which rounds to what?
0.35.
0.35. Lorena, how do you get your number?
Because I had subtracted the 2.35 and then I subtracted that from the 2.896.
2.896.
Yeah,
Where do you see 2.896?
I don't know. That's the number I heard that they have said right now. So I was like,
2.698.
oh, and I miss.
All right, do 15, please. Someone get 15 correct. This is a confidence interval. Okay. All right, what do we get?
I'm getting the average right now.
Okay.
Is it C?
It is C.
Yay.
Yay. Number 16, is there a significant difference between the mean sizes of the muscle gap for Caucasians versus Chinese men? Okay. What's 16? Which one do we use for this one?
I did 2 sample t-test,
Okay, love it.
and then I got 1.1. No, I have the answer, but I don't know which one is the answer.
Well, what do you have as your T statistic? On your
2.466.
calculator, huh?
2.466. Oh, so would it be D?
Yes. So is there a significant difference?
Yes. Wait.
I don't think
Yeah.
I don't think it actually asked for it, but is there a significant difference?
I mean, yeah.
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 And alpha equals 0.05.
Huh?
What alpha are you using?
What output unit?
What alpha are you using?
0.05.
And why do you say there's a significant difference?
Because it's way larger.
It's way larger? What p-value do you have?
Oh, never mind. I have 0.01.
And therefore it's smaller. So is there a significant difference?
Yes.
Okay. The answer is yes. If the p-value is low,
Let the null go.
and if the p-value is high,
Let it fly.
let it fly. In this case, it's low, so the p-value must go. What is the degrees of freedom via the conservative approach for this problem? Not what the calculator gives you, but the conservative approach. What's the degrees of freedom? And what does the calculator give you, by the way, for the degrees of freedom?
73.1 about.
So what is the conservative? Of those four, A, B, or C, or D, only one of them is even possible.
54.
Why not the other ones?
Because it's the smallest one.
Yes, but not just the smallest ones. All the other three are bigger than 73.1.
Yes.
Okay, so the conservative must be smaller than the true value. Otherwise, why is it conservative? Yes, no, maybe so.
I was going to say something, but I didn't say it.
What are you gonna say? Go ahead.
I think Edward was thinking the same thing. So,
Well, what is that we're gonna say?
what were you going to say, Edward?
Are you guys together in the same place?
No.
Anything.
You're the psychic? Huh?
Yeah, we're psychic. We're like telepathic.
Cool.
We're cool like that.
Yeah, I'm not cool. All right. Anywho, guys, you need to go over this stuff and stuff before the test. You gotta go over it. Yeah, well, that's the review. So I'm gonna stop sharing or stop recording.